Just checking, can you see the whole screen or can you just see my presentation?
We can see the whole, we can see your presentation.
Cool. Great. Well, thanks very much for the opportunity to present today. Yeah, it's been a really exciting program, the MEDApps projects. And so just a quick introduction to myself and the project, and also some of the presenters that we'll meet today. So our project is called USmart0, and as Fabio said, it's all around this kind of key challenge around supporting fuel-poor households. And we're doing that through integration of different interesting data sets and novel data sets. And on our program, we also have my co-founder Stevie, who's going to take over and talk a little bit more detail about the data science, and Matt from DCC, which is one of the really interesting data sets we managed to utilize for this project. Heather from the Greater Southeast Net Zero Hub, and she'll talk a little bit more about the practical application of it, as well as Owen from UCL, who helped with our data validation process. So I'll just kick off and give you a quick overview of really what we're going to talk about in this next 20-minute presentation. So I want to give you a quick introduction to ourselves, so just get a little bit of background about who we are and where we've come from. Then I'll dive into a bit more detail about the challenge that we're trying to solve and some of the goals around that. And this is a really kind of long-term challenge, so kind of really what we've identified in this first phase, some of the metrics around that initial delivery. And I think it's really important to kind of get into the DCC. Are going to talk about the overview of why they've been involved in the project, and also a bit more about the process of how they've enabled us to utilize some of their novel data set. And then crucially for us, this is really a big challenge on the data science side. So we've got a bit more background about the process that we've gone on to develop some of the insights that we've developed to date. We've got a short demo, just a quick video at this stage, and obviously happy to dive into more detail with folk later. And then into how it's being used. So some of the beta testing that we've done with the Greater Southeast Net Zero Hub, as well as Connect to Place Catapult has been supporting that. And then finally, our kind of next steps, where we want to go next with this program. So just a little bit about us. So so I'm Simon Tricker, co-founder of UrbanTide, and our mission is really to help organizations to unlock data and then to utilize that and build AI for good. And our long-term goal is really to build an AI portfolio. So we want to develop a number of interlinking AI tools that really help to tackle some of the big global sustainability challenges. So our long-term mission is really around making a sustainable world and utilizing AI to help on that journey. We've been around since 2014. We've really kind of focused in on a number of different sectors. Initially, we focused on the public sector space, so really working in the smart city space. So trying to link lots of different cross-sector data together to try and open up as much as we can, and then also starting to link that. We've then moved into transport and energy spaces because they've got lots of interesting real-time data, and we work with a number of partners on utilizing IoT data. And then that's kind of really led into the housing space as these things start to converge, especially into sort of the built environment, as that's obviously a big contributor to some of the sustainability challenges that we face. So the challenge of this project is a big one, and obviously it's growing. So we're really looking to tackle the growing fuel poverty crisis, which is just doubled and tripled since we've been working on this program. It's obviously you're all aware of the cost of living crisis. So I think having this tool available and starting to help it to expand is really kind of key opportunity to try and help to reduce and mitigate some of this risk. So as I said at the start, really, this is a long-term program, and some of our goals are kind of across a number of stages. We've tried to kind of group these into these three buckets. So our first phase, which is really what the MEDApps has helped us to focus on, is this identification problem. How do you identify households and areas that have a higher risk of fuel poverty? So to do that, we've been linking some new data sets together, and really trying to utilize the potential of using real-time data and analysis to enable a much more comprehensive and real-time view of where areas are highest risk. And then obviously what that can then help to do is then in the intervention stage, with more accurate targeting, we can then help to support areas and households that need support, as well as helping to identify which properties will have the highest potential for retrofit solutions and which ones could be suitable candidates. So that's our kind of next stage of development, is into starting to build up more of that assessment tool. And then ultimately, we want to assess the impact of all of these measures. So how do we create sort of feedback loops? So how can the data feed back on itself to check as the interventions go in, that they do start to have an impact on not only reducing energy and CO2, but also trying to reduce household bills and reduce this fuel poverty crisis that we face. So just a few of the key metrics from this program. So it's been well funded, which has really helped. It's been a long project, 2 years. I think it started back 4 years ago. We started initial discussions with trying to utilize some of the data to solve this, and then sought this funding, which has really helped us to link a whole host of different data sets. So I think that 1 billion cross-sector data points is probably an underestimation now of all the different amount of data points we've managed to bring together. And one of the key ones there is the anonymized smart meter system data. So this is a really interesting data set, and Matt will talk a little bit more about what that is, and then we'll get into how we've used that to develop our custom AI. And then UCL have helped us with the validation of that, because they have some interesting data sets that are much more granular. So ours is quite high level and theirs is more granular, so we've helped to kind of merge and see what the validation process is between those two things. We've developed a number of different indicators, and we're just beginning the trials now with a number of local authorities, and Connected Place Catapult, as well as the Greater South East Energy Hub, have really helped us on that journey. So I'm just going to introduce you to Matt, who's just going to talk a little bit more about the DCC's perspective and why they've been involved. Over to you, Matt.
Brilliant, thanks, Simon, and hi, everybody. Yeah, so just to give a very quick bit of context, really, from DCC's perspective, we've been participating in this project as part of a wider activity to try and maximise access to smart meter system data, and really for public benefit purposes. And we've been doing that under a programme that we've been calling Data for Good, and so participating in this project has been a great opportunity to move this forward, and really the main drivers for us have been, firstly, it aligns to policy priorities, both in terms of better data use, but also specifically in relation to better data use to help reduce fuel poverty. There are some really good recommendations out there. Secondly, it's been a chance to establish tangibly how system data access can actually be shared, and how it can help to deliver public benefit. And then thirdly, and kind of related to that, really, it's given us a chance to understand the wider implications of system data access. So, particularly from a regulatory and data privacy perspective, some of the issues that we've needed to work through. So it's been really helpful, and it's put us in a great position to actually start looking at additional use cases too. If we just move on a slide. Thanks. So just to talk a little bit more about smart meter system data and the way in which it's being used for the project. The smart meter system supports about 140 different message types that can be sent to and from connected devices. And with the volume of devices that are now installed, that's generating near to 1 billion transactions per month. Because of the encryption model and data privacy implications at DCC, we don't see inside those messages, but what we do see is the data around them. So what we're talking about in terms of system data is really those transactions, which messages went to which devices and when, broadly speaking. And so that system data is derived from a number of different sources, so registration data, device inventory data, and then also that audit trail of messages as well. So that combines to create quite a unique GB-wide data set. And so for the purposes of this project, what we've been exploring is whether a combination of system data, particularly relating to prepayment meter transactions and low credit alerts, can be used to help establish areas where there may be a greater prevalence of financial difficulty and fuel poverty. I think Stevie's going to go on and talk a bit more about how the model works and the data science within that. Because of the nature of the data, it's been really important key aspect here has been data privacy, and we've worked really hard to ensure that the risk of any kind of consumer harm is absolutely minimised, and we're very comfortable that it's incredibly low. In terms of modification of the data, what we've done is firstly anonymisation. So we have a randomly generated device ID within the data set. So we've managed to retain individual records, but there is no link back to identifiable data. That's deleted at the point of generation. Secondly, the data's been aggregated. So whilst there are individual device records, there's no address information in there. They've been aggregated to lower super output areas. That's about 600 homes on average. And then finally, we've actually obfuscated the time and date of the message, the transactions as well a touch. Also, as you'd expect, we put really robust technical security measures in place. And so whilst the data modification has been really robust, we have managed to retain some utility in the data, clearly. And I think Stevie is just going to go on and talk about that a little bit.
Great, thanks, Matt. Right, Stevie, I'll just click over and leave over to you.
Great, thank you, Matt. And yes, following on from the data you've delivered to us, a little bit of information on that data. So as we receive a big data set like this, I suppose the first thing you do is to try and understand if it matches the real world context. So we've obviously did months and months of exploration into the data to understand it, what the size of the data set is, and to just make sure it relays what's happening in the real world effectively. So we can see some meaningful correlations at that sort of level. So on the right hand side, you can see graphs that show as prepayment meter propensity goes up, so areas with more and more prepayments, that also links with people on higher universal credit. So that goes across the whole of the country. As that goes up, so does the prepayment meter connections. Similarly, as universal credit goes up across the country, we can also see electric and gas disconnections go up as well. Electric has got a bit of a stronger correlation than gas. So you're understanding the real world context within that data set. And then also we saw that the number of messages hints at sort of prepayment disconnections as well. So understanding it makes sense. And then again, months of work effectively running through different AI and machine learning processes to find ones that give us the best modeled results to indicate fuel poverty. So we utilize the hidden Markov model, and the key outputs from that is that we're able to group different meters together in the way they act into those that are struggling to stay in credit and those that are effectively always in credit as a proxy for being in fuel poverty and not being in fuel poverty. Move to the next slide, Simon. Thank you. So obviously that's kind of an assumption that you make, and then you want that validated. So with part of the project, UCL and their Smart Energy Research Laboratory have got high quality data for individual households effectively and householders and how they are, their fuel poverty situation effectively. And on the high risk area where Searle identified high risk households, we identified all of those high risk households as well, and we also identified more of them. The overall match gave us 64% validation against what would be a random score of about 33%, so double the kind of random score that you would get. So that across all levels of risk for fuel poverty, use Smart Zero performed well at that stage, and that's obviously something we look to improve upon. And then finally, the idea that we're exploring at the moment with the data is that as messages go up in general within a population or on a household level, that is indicative that the next month there might be a disconnection. So you're seeing a little bit more sporadic use of the meter potentially, which indicates that in the following month we might be moving to a state of disconnection. So it indicates again fuel poverty with that level of message being used. So I'd like to pass over to Sai to take you through the product now.
Great, thanks, Stevie. Yeah, so that's just a bit more background really around the data set from DCC, and then also on the data science side. And then I'll just give you a quick view of the product itself. So as I said, this is kind of early stage. We're really focusing in on the identification component first. So we've developed linked a number of different data sets together and then presenting those into a map-based view, which effectively allows us to view, at scale across a local authority area or larger, which areas have a higher prevalence of potential risk of fuel poverty. And then as well as on there, we're also linking some of openly available data sets like EPC data to allow sort of individual household ratings to be viewed as well. So it's trying to sort of go to the next stage of what could be an intervention. So I've just got a short video that I'll just play through. So this is effectively our platform, USmart, which allows us to integrate effectively any data from any source. And then our tool is one of the tool itself is within our reporting component. So effectively, we've chosen one area here in Hillingdon, which is interesting, kind of a mixture of demographics. Load up the data. This allows us to go into an OA level. So although the LSOA data, we can also look at an OA level. And then instantly we get a risk score, which pops up, which is derived from a number of different sources, including smart meter data that we just talked about, the EPC certificate data, so aggregated across that area, the universal credit, again, from the LSO A level right across to the region. And if we click on another area here, we've got a smaller zone, which is of higher prevalence, higher potential risk. And again, we can kind of go in and then start to see some of the energy rating certificates information about those specific properties in that area. We've also linked with the Bayes fuel poverty, which is an historic data set, which is why it's quite a lot lower, as well as the index multiple deprivation and smart meter penetration across that area, as well as non-gas, because that's another contributing factor as well, properties that are not on gas. Importantly, about filtering. So we've got a number of different ways of filtering down that data. So starting to allow us to look at some of the subsets within that and reducing down the amount of areas that want to be identified. So again, we've kind of filtered it down to a smaller subsection. And that allows us to then go in and to see that area in a bit more detail. So again, we've got a couple of different ways of viewing the information. So sort of classic satellite view as well as street view. And then again, toggling on the different layers allows us to kind of go in and see the key information. Now, our kind of goals next stages really is to integrate other data sets around the property and to view it in different ways as well, and kind of looking at the types of houses that we're looking at here as well. And then I think the last piece of the demo is allows it to save these key areas, and those key areas can then be exported out as CSVs, as well as enabling us to filter the data. We can also save out those subsets of filters. And again, nice and quick and easy way of doing that, and also choosing which data sets you want to export out. Great, so it's just a quick demo. As I said at the start, we're kind of really focusing on identification phase. And we've done a lot of sort of on the data science side. So now it's into the next stage of how we develop our tool, which we've been doing with the help of the Greater Southeast Net Zero Hub. I've got Heather just to talk a little bit more specifically about what they've been doing, how they've been helping us. If you're there, Heather.
Thanks, Simon. So the hub covers an area of 136 local authorities, and we're currently delivering a domestic retrofit scheme across the whole hub area through Bayes funding. And this is going to continue through to the end of March. So we've got a lot of interest in terms of finding out what's going on in terms of where eligible homes for retrofit. We've got over 10,000 more homes to find by the end of March next year. So we're very keen, because it's a fuel poor focused retrofit scheme, to look at different ways to find where these homes are, to use all sorts of different innovative data sources to try and do that. And I think the real sort of interest here with this data set is that actually potentially very up to date. It reflects where actual current fuel poor homes are, rather than sort of backward looking statistics we quite often have to work with elsewhere, and also potentially substitutes things like local knowledge with allowing us the capability to find perhaps homes that even people who've worked in local authorities for years might not actually be aware of. There might be some looking at the data, there might be some hotspots of homes which are currently sort of missed on the radar by taking a data-led approach rather than using people's local experience, etc., which can only be so good. So we've tried to encourage our local authorities to support the delivery of the pilot work with UrbanTide, to get them engaged with the different interventions that Connected Places Catapult have done to support around delivery of the project. And we're very, very supportive of any work that can kind of proceed to open up with data sets here for public good as well. Thanks, Simon.
Great, thanks very much, Heather. And yeah, importantly as well, to kind of support us on that user validation journey and evaluation journey of this, we worked with Connected Places Catapult. So this started in the phase 1 initially, talking to lots of different user needs across the whole of the UK, really to kind of drill down and understand what the kind of core problem was. And as you kind of Heather just kind of alluded to there, it's really a lot of it is around supporting local authorities with that kind of bid readiness component. So they have a number of different funds that they need to then identify properties that have the right kind of attributes to then support them through retrofit programs. So it's really exciting. We're in the initial trials with a number of different local authorities across this program. Just flick through there. So across the country, really, just beginning those trials. So starting to look at how they've currently done it, how they could use our tool to support that process, and then again how we can kind of help to support them on the ongoing data integration, as well as the identification and the intervention, and then also the impact. And then lastly, last slide, just on kind of our next steps, really. So this is a long-term project. So we're really on a long-term journey with continuous iteration, continuous development with our customers. Starting to explore the enduring use with DCC so that we can keep up-to-date data and refine our models is a really kind of key piece. Obviously, there was the price cap increase in April, so we're keen to get a new data set to look at how that has impact and start to support some of our future predictions for the increasing price cap, which is coming in October. Adding some more data layers and features, and then ultimately we're ready to launch on G-Cloud 13, which is the government framework. We're also on a few other government frameworks, but G-Cloud 13 has just come back on, and that launches in September. So we're looking to have our product ready to launch for them. Great. So if you have any questions, obviously got time to answer those now. And if you want to get in touch, then there's my email address on the screen there. Thank you very much.
Great presentation. Thank you, Simon, Stevie, and Heather. Thank you, everyone, and Matt. We have a first question in the chat. Have you explored collaboration with suppliers or energy retailers?
Yeah, so that's a really good question, and we're in the beginnings of that journey with suppliers. So just starting to build connections, really identifying which are the right teams. So there's obviously the kind of the customer-facing teams. So quite keen to see how our tool can start to support them. Initially, the project was our sort of use case was more on the local authority side. But we can definitely see support with the networks as well as the suppliers as well. So yeah, keen to develop that.
Great. We have another question. So explainability is an important aspect of this, of AI and machine learning. So how explainable is the score that your model outputs?
Yeah, cool. I'll probably let Stevie talk through that one in a bit more detail. Thanks.
Yeah, no, it's a good question. I think the key thing for us there is to look at the validation side, so that it's proving that what we're producing as an output is valid in the real world context. Hence the link with UCL and Searle. I think to simplify what we've created is quite easy to explain in terms of the meters that are struggling to stay in credit are acting in a certain way, and the meters that are always in credit are acting in a certain way. That's a proxy for fuel poverty at this stage. One that we believe is very accurate, but we know there's some outliers in there. People that are, say, for example, always in credit would still meet fuel poverty definition if you were to speak to them. But on the wider context of that, you're creating an output that very simply is linked with how the meter is produced. And that's why we wanted to talk about that today, to very much show you that rather than just to give you an output score that was kind of meaningless. So it comes from that, and then it comes from the context of trying to make sure that that's replicated in real world conditions. And hence, as I said, the link with Searle. I don't know if there's anything when you would pick up on that.
I'm sure if you have,
if we have. Oh, sorry. Can you hear me?
Yeah, please, yes, please.
Oh, yeah. I was just going to jump in there on that question. I think the one thing that we sort of needed to figure out first was, well, is it possible to explain the score, right? And so that's one of the key outputs that we were trying to do in partnership with UrbanTide and doing this validation step. And I mean, the answer to that is that yes, it is possible to explain the score in the context of the detailed data that we collect in the Smart Energy Research Laboratory. So I think that was one of the kind of key outputs of the project. We were able to show that it is possible to do that, and we were able to provide a sort of a small amount of contextualization of the model output of UrbanTide.
Thank you. Thank you for this. I'm sure if there are further questions on the topic, we'll see them in the chat. Carry on. Another question I received is, well, you talked briefly about the three kind of steps of the journey, like identification, intervention, and impact. And you briefly mentioned that you are looking at now intervention, so what measures to be installed in the identified properties. And do you have any ideas on how you will do that? Do you have any, can you tell us a bit more of how you're doing, how are you going to do that?
Yeah. So I think there's, it's an interesting challenge. So there's kind of a number of components that kind of go into helping to build out one of the key challenges is really around scale. So how do we look at a number of buildings at scale? So we're looking to utilize some more of the sort of street view type imagery to try and classify buildings. And there's a number of different components to this. So we're kind of in early stages of how we're going to build that out. We've got some initial development that we've done in this area. And then looking to progress that. And then the second important part is then also around the impact. So starting to assess, so, if this property A, has a potential of going from an E to a C, then how does that translate across other properties across that area and have similarities as well? So trying to use some machine learning tools and techniques into assessing a broad spectrum of similar properties.
In order to build a portfolio of projects, basically. That's it. Or similar projects in the same area. That's very, very helpful for financing, I guess, these interventions. Great, brilliant. Well, thank you to all the speakers. Thank you, Simon. Thank you, Stevie. Thank you to the UrbanTide team. And I guess we reached the end of this event for today. So please, all the participants, if you have any questions, if you want to engage with these projects, please get in touch with them. I'm sure they will be more than happy to answer any question and to engage with you all. And we will leave the chat open for a few minutes in case you have some last minute questions. Thank you everyone for coming today, and we will have the second day of the second round of show and tell tomorrow, where we will have other 3 projects presenting And yeah, so I hope to see you tomorrow as well. Have a nice day. Thank you again.